Hello and welcome to the 12th video lecture of Quantitative Analysis for Business Decisions QABD semester number 2 model number 1. In today's video lecture we are going to continue with presentation of data. In a previous video lecture we have seen about presentation of data and introduction to it, and also one dimensional diagrams. Presentation of data can be done in two ways, that is you can either draw diagrams or graphs. In that, the first part, that is diagrams, we are covering, and in that we have one dimensional diagram which we have already covered. In today's video lecture we shall be seeing about two dimensional diagrams and some other things. So let us begin. So what are these two dimensional diagrams? As the name suggests, these diagrams have two dimensions. In two dimensional diagrams, the area represents the data. In one dimensional diagram, we have seen that we only consider the height or the length of the rectangle or maybe line. But in two dimensional diagram, we consider both the length and the breadth, that is its area, into consideration. Such diagrams are also known as area diagram or surface diagrams. There are three main important types of two dimensional diagrams. They are rectangles, squares, and pie diagrams. We shall see one by one all these three things. First one, rectangles. So what are these? Rectangles are used to represent the relative magnitude of two or more values. So with two or more values can be shown here on a rectangle. The area of rectangles are kept in proportion to the values. How to do this we'll see by a simple problem. Rectangles are placed side by side for easy comparison. When you keep it side by side, then only it becomes easier for comparison. We may represent the figures as they are given, or may convert them to percentages and then subdivide the length into various components. Now how to do this, I'll tell you. First of all, rectangle. Now let's recap a little bit about the simple bar diagram. Simple bar diagram is actually a rectangle itself. So these rectangles, whatever we are drawing here, will be similar to your bar diagrams. In this we have said, the last point here, it says that it can be converted into percentages also, or the original values can be taken. So these are either component bar diagrams or percentage bar diagrams. So such kind of things can be done. We'll take a problem into consideration and we'll try to solve it. By solving this, we'll get to know how to do this. Represent the following data by subdivided, that is component, percentage rectangular diagram. So we need subdivided plus component, subdivided plus percentage. Both we have to take into consideration and we have to draw a rectangular diagram. Now items of expenditure of a family: food, clothing, house rent, everything is given. Two families are there, family A and family B. So definitely they have said percentage here. So we have to, first step is we have to find out percentage. Total in this table may be given, like in this case which is given 5,000 of family A and 8,000 of family B. Sometimes total may not be given also. In that case you have to find out. So just like this percentage bar diagram, we are finding out the percentages. Here family A and family B, Y represents the percentage. Okay, so 40%, that is, how does this 40 comes for family A? The first value of Y, it is 2000 divided by total, that is 5000, multiplied by 100. So 2000 divided by 5000 multiplied by 100, you will get 40, and so on. For both family A and family B you have to do, and you will get percentages. These percentages need to be plotted on the graph paper and you will get diagram like this. Legends have to be shown. This type of thing we have already done in percentage component, that is percentage subdivided bar diagram. So similar thing it is, that is why I have not explained much. You can see my previous video lecture for this percentage subdivided bar diagram. Now let us move towards the next type, that is squares. Now square, as we know, it is different from rectangle in the sense that all the sides of a square are same. That is why we call it a square. That is, all are equal, all sides. The rectangular method of diagrammatic presentation is difficult to use where the values of items vary widely. So whenever the values are differing a lot, it is difficult to show it on a graph paper using rectangular diagram. We need to use square diagrams. The method of drawing a square diagram is very simple. One has to simply find out the square root of the values and then plot them. That square root of the value will give you an idea about what should be the size, or what should be the length of each side of the square. So such kind of things can be drawn. We'll see a problem and how to solve it. We'll see. Yield of rice in kgs per acre of 5 countries are given: USA, Australia, UK, Canada and India. And you can the values are also given. Represent the following in a square diagram. So to find out this, we first write out country USA, this, then its yield, whatever is given. The first two columns are given. The third one you have to find out square root. You have to find out. So square root of 6400 you have to find out using calculators, that is 80. Square root of 1600, that is 40. Square root of 2500, that is 50, and so on. Then what you have to do is you have to take into consideration certain measurements, and that is you have to take a scale. See, 80, 40, 50, all these are certain based upon certain scale. You have to convert them into centimeters. That is, if I take 20 units is equals to 1 centimeter, suppose if that unit I am taking, then 80 centimeter, 80 units means how many? 80 divided by 20, that is 4. I'll show you here calculations. See here, 6400 is there, its square root you have found out 80. 1600 is there, its square root you have found out 40. 2500 is there, its square root you have found out, that is 50, and so on. So once this is done, the next step is we have to find out. See, directly we can plot using saying 80 centimeters as the side. So all the sides should be 80 centimeters, but it becomes difficult to plot such a big square in your answer sheet. So what we do is we reduce it. Say 20 units. 20 units means 1 centimeter. Okay. So if I am saying 20 units means 1 centimeter, 40 units means 2 centimeters, 60 units means 3 centimeters, 80 units means 4 centimeters. So that is what they have said. Scale you have to write scale 20 units is equals to 1 centimeter. So this way you have to write the scale. So by writing the scale you will get this 4 centimeters. Simply what I am doing is 80 divided by 20 is 4, 40 divided by 20 is 2, 50 divided by 20 is 2.5, 60 divided by 20 is 3, and so on. So this is what I have done here, and I've got the scale. So this is the side of centimeters. You can just what you can do is, if you're feeling this is difficult, what you can do is you can neglect these zeros here, and you can draw squares of 8 centimeters, 4 centimeters, 5 centimeters, 6 centimeters and 7 centimeter at this side. So this you can do if you want. You can neglect this zero. So what I am doing is, the scale here is 10 centimeter means 10 units means 1 centimeter. That unit you have taken here. So whatever, either ways you will get the same thing. I am drawing the squares. USA 4 centimeters, Australia 2 centimeters. So all these sides will be same. This is 4, this is 4, this is 4, this is 4, this is 2, this is 2, this is 2, this is 2. Similarly, this is 3, this is 3, this is 3, and this is 3. So 3 has come from here. This is Canada. Okay. So very simple it is, squares. The next type of diagram, very important and probably generally asked. So in your examination, they from previous experience, we can see that they will either ask you a pie diagram, that is a pie chart, or a histogram. So histogram, where it's later it comes in graphs. Pie diagram, we shall see how to construct a pie diagram. Now what is a pie diagram or a circular diagram? In such diagrams, both the total and the component parts or the sectors can be shown. That is, it is a two-dimensional diagram itself, but it is in the form of a circle. A circle is done and various sectors are cut based upon the area. Each area represents certain parameter. The area of a circle is proportional to the square of its radius, remember. So that is mathematical in nature. We shall see how to solve it. Now, example, draw a pie chart for the following data regarding production of sugars in quintals of various countries: Cuba, Australia, India, Japan, Egypt. Various production of sugar is given in quintals. So what we have to do is, we have to convert them into degrees. We know that the entire full angle, that is the whole angle which is there, complete angle we call it, is 360 degrees. So an circle, so when you are going along the circumference of a circle, suppose this is there. Now when you are going this way completely and coming back to the earlier position itself, that means you have traveled 360 degrees. So total is always 360 of the entire circle. So this has to be divided proportionally based upon this Cuba, Australia, whatever sugar productions they have. So now how to do that? First find out total of entire this. So total sugar production is 166. So now you have to convert them into degrees. So it will be, if you want to convert them into degrees, it will be 166 into 62 upon 360. Okay, the answer for which is 134. Sorry, there was a mistake from my end. It's not that way. It is 62 divided by 166 into 360. Okay, the same like percentage itself. What we are doing here is this divided by the total, multiply by, instead of 100 you take it as 360 in pie diagram. So 360 is fixed because in percentage total was fixed as 100, so that is why we have multiplied by 100. Here in pie chart the total number of degrees is 360, which is fixed. So 62 divided by 166 into 360 is 134. So this is what we have done. After that, next Australia, to find out that, again it's easy. It is 47 divided by 166 into 360. So this value you will get, yeah, 102. So similarly you find out for all, the total of degrees will definitely be 360. So now we know the degrees. Now what we do is, take your compass and draw the circle. So the first step is drawing of this circle. Then from the center you draw a horizontal line wherever you want. It might be here, there, wherever. In this case here, these people have taken the line here. Any line you can take. It should meet the center and the point on a circumference. The first, if you see, first thing, that is 62 degrees. Okay, 62 degrees, which it is Cuba. So let's see, this circle I have drawn, this this is the center. Now from here keep a protractor. Suppose your protractor is this way, with 0 here and 180 here, and now calculate where is that 62 gone. Just see, sorry, 62 no, 134. Where is that 134 gone? So your 134 is, either way you can go, either clockwise or anti-clockwise. Here they have gone clockwise, so your protractor is this way, 0 is here, 180 is here. Now go and measure and find 134, whatever angle it is for the first country. So there you will draw one this. Then now what you do is, the next step, for the next country you need to draw now the second angle. So for that what you do is, the next is 102, that is Australia. So after Cuba we are going for Australia. So circle is there, the first this is there, you have drawn 102. Then the next one is this one, the next one is this, and the next one is this. And slowly you can do for the second one. What you have to do is, see here, the first one you got, second one you have to keep protractor this way. 0 is here, 180 is here, and then mark the next one, okay, from here. So this is how you have to draw pie chart. Fine. So this is about two-dimensional diagram. A detailed video about how to draw pie chart will be sent to you on YouTube. I'll will be sent to you later. For the time being, just understand what pie chart is and how basically it can be drawn. Pie chart, I'll send you one more video regarding it. The next one is three-dimensional diagram, that is volume. As the name suggests, three dimensions are important along with length and breadth, or you have height or depth also, that is more important. In such diagrams, three things are important. Of all the figures, making of cubes is very easy. So we generally use cubes. You can also use cones and all, but cubes are generally used because they are very important, very easy to draw. Just like this squares, when we in two-dimensional diagrams we had found out square root. Now here to find draw cubes, we are finding cube root. So here represent the following in a volume diagram, that is under UG students, PG students and professionals. So the same thing I've copied in first one and second column. Now I'm finding out cube root of that. So cube root of 64,000 is 40, 30 is the cube root of 27,000, and for 8,000 the cube root is 20. Now again use some scale, say you neglect these zeros here in the end. So 4, 3 and 2, that is 10 units is equals to 1 centimeter. 4 units equal to 4 centimeters, that is what you have drawn here. Similarly, you find out now draw cubes with 4 centimeter as side. In a cube, all the sides will be same. So cubes have to be drawn and it should be named UG, PG and professional. Generally, this is not asked in your examination. Then lastly, we have pictographs and cartographs. Now pictograms and cartograms, or pictographs and cartographs. So pictograms are not abstract presentations such as lines or bars, but really depict the kind of data we are dealing with. For example, you want to show number of animals which are there in a zoo or in your in a room. Suppose 5 rats. So you draw rats, 5 different rats, and you show 5 rats are there. Then you show this so 2 cats are there. So you draw 2 images of cats and show that there are 2 cats. Pictures are attractive and easy to comprehend, and as such this method is particularly useful in presenting statistics to laymen who do not know. Layman means who do not know anything about statistics. So this becomes very easy to comprehend. When pictograms are used, data are represented through a pictorial symbol that is carefully selected. Cartograms or statistical maps are used to give quantitative information as geographical basis. They are used to represent spatial distributions. The quantities on the map can be shown in many ways, such as through shades or colors or dots, or placing pictogram in each geographical unit. Example of this will be shown to you now. You will understand it better. So this is an example of apples sold here. Apples sold in January. This does not mean that only one apple was sold or 1 dozen or one box. Down you have to see what is the label. One diagram of apple means 10 apples. So total 10 apples were sold in the month of January. In the month of February, you have 10, 20, 30, 40 apples. In the month of March, you have 25 apples because only half apple is there. And in the month of April, you have 20 apples that were sold. So this way there are many different pictograms that can be used to make statistics understanding very easy. With this, we end today's lecture. I hope you have understood today's lecture. Theory notes of this will be sent to you. In this only how to draw pie diagrams, that was the most important point. Video for this, I'll be sending you a link for this once more. Okay.